Alright, so today we'll be working on some image filter. This will be the end result. This is using OpenGL. We are going to start by only using P5 and JavaScript, and then we'll go through and use OpenGL to reproduce what we've done with JavaScript. Alright, let's get started. So, we have our image here. It's a bit small, but it should be fine for the purpose of this video. Great. So the first thing that we'll need to do is load the image into the canvas. We'll set some variable for the image data, and we will use the function preload. From this function, we'll just set the image is going to be equal to the load image function from P5, and we're going to pass it the file itself. So in our case, it's going to be image.png. Save this, nothing has changed. That makes a lot of sense. Then what I want to do is update this canvas so that the width and the height are based on the image, right? So image.width and image.height. There you go. There we go. Okay, perfect. Now I'm going to remove the draw function for right now, just because we don't need it. We will be adding it back afterwards. Now, what we need to do to display the image, well, there's multiple ways, but the way I want to use is to load every pixel of that image, since we're going to be updating every pixel of it, right? So what we'll first need to do is load both the pixel of the image and the pixels of the canvas. To do that, we can use the image.loadPixel function. And the same function exists also for the canvas, so just calling load pixels. There we go. Awesome. Alright, this didn't change anything, which makes sense. We will have the full length let pixels, and this is basically just going to be the amount of pixels that are inside of the image. To get that number, we'll need the pixel density. Let's just call it density, or D in short, and we call it pixel density. There we go. And with that, we will just calculate the density plus the width and the density plus the height, I believe. Yeah, that should be it. Right. Okay. Sorry, not plus, just multiply the density by the width and the height. There we go. Okay, so this is the amount of pixels that are in our image and at the same time in our canvas, since they share the same dimension. Great, so now we can do a loop which goes through all of those for let, and we can call the index variable index actually. We could call it I, it doesn't really matter what it is as long as it's less than pixels. Oh, and I might want to give this a different name. Pixel count. Just because I believe there is some variable in P5 that we'll need that is called pixels. We'll see. Anyway, I can always update it later on. So now we're pretty much done. We just need to display each of the pixels, right? So let's get the pixels of our image. So one pixel will contain, well, why we multiply by 4 here is because every pixel will have 4 values. First value will be the red value, and then the green value, and then the blue value, and the last one is the alpha value, right? So that's why we multiply the amount of pixels that we get by 4, because there's, for each pixels, there's 4 value that we need. So it's basically going to look something like this. So we get the image, and then we get its pixels, and then its pixels at the index is going to be R, right? Red. And then I believe I'm wrong here. I need to move it by 4, right? So, right, because we will get 1 pixel here. So let's duplicate all of this, and it's going to be +1, +2, and +3 for the last one. There we go. And I'm just going to put +0 here just so that we're consistent. So R, G, B, A, right? So now we can just draw the image onto the canvas using pixels. Yeah, there you go. So pixels, and basically it's going to be exactly the same as this. Though this time it's not going to be image.pixel, it's just going to be pixels because it's the canvas pixels. There we go. And we're going to set it equal to, in this case, R, G, B, and A. There you go. Now it is not showing anything because we haven't updated the canvas pixels yet. We just need to call the update pixel method, and there we go. So there is a small issue here. What is it due to? Okay, so I think I found the problem. Setting the pixel density to 1 seems to fix the issue. I'm not exactly sure on what this is caused by. It could be because like the density of the canvas is higher than the density of the image, which should just be 1 for the density of the image regardless of the image. Might be due to like the screen that I'm using, which is the Retina screen from the MacBook, which I believe pixel density is 4. Let me try 4 and see if we get the same result. No, maybe 2 though. There you go. Yeah, so the pixel density I have on my screen would be 2, and the image is 1. So now I've set the image, the canvas pixel density to 1, then we see the image as is. And also I just thought that I can remove this pixel count here and just use the image.pixel length, right? There, right? We don't really need the pixel count since it's already counted inside of here. There you go. All right, so we're displaying our image using the pixels of the image and setting those pixels for each of the pixel of the image into the canvas. All right, next, what we need to do now? Well, we're pretty much done. Now we need to do the in terms of displaying the image. Now we just need to do our filter, right? So let's say we wanted to do this as a monochromatic image, right? Let's say we wanted to apply it as monochromatic visual, right? So what we can do to get the luminance value of every pixel, we just need to add all of the pixels value together and divide them by 3 times 255, right? Because the max value of 1 pixel can be 255. Well, not 1 pixel, sorry. I'm going to say this a lot more again in this video, but let's say the R value, its max value is like 255, and same for R and G and B, right? So we want the cumulative of that value, which will be just R plus B plus G, R, G plus B, whatever, it's pretty much the same. And we'll want to divide this by 255 times 3, right? So we get basically the average, the mean of the pixels. And this would be the luminance. And this luminance value should show us the chromatic value. Oh no, sorry. It's just divided by 3, right? There you go. Yeah, my mistake. Awesome. Cool. So now that we have the chromatic version of this image, we can do a lot more, right? We could show anything that is less than, I don't know, 200 luminance as black, or less than, let's say, 100 luminance as black, and anything else as its luminance value, right? So let's do that. So let's say if so let's say, yeah, okay. So if the luminance is, and I'm not sure luminance is actually spelled that way. Let me just check. Yeah, okay, that's okay. Cool. So if the luminance is, let's say, smaller than 100, and let's just have that value be equal to luminance, or we can just use the luminance value itself, the luminance variable itself. So if the luminance is less than 100, then let's set the luminance to 0, right? So anything that is illuminating less than 100 will be black. Anything else, so higher or 100, will be what it actually is right now. So let's try this out. Right, so anything that is less, let me go back just to show you. Let me just, I guess, comment this out. See, all of this grayish part will be blacked out. And we can change this value to make it more, to make it like, this would be like the threshold. So we can change this to a bit more. So we have more blacks and highlight a bit more of the rest, right? I'm going to make this into a variable just for our ease of use. So let's maybe call it the threshold. I guess it's a fine name for it. Threshold. There we go. And for right now, let's leave it at 150. I like this. It's fine. There we go. Threshold. So another thing that we could do is maybe map. So let's do this. So anything that is not small, anything that is smaller than the threshold will be 0, and anything else will be its original color. So to do that, I'm going to cut this, paste this in here. Whoa, there we go. Paste this in here. Okay, and what we can do now is just, this is basically going to be 0, like we said, and this is basically going to be what its original value was. So R, G, and B, right? So now we only highlight anything that is higher, that has higher luminance than our threshold of 150. Cool, this looks nice. Now, what we want to do now, we could maybe highlight the specific, so we could make those pixels not as they were, but more colorful, right? So instead of just RG and B, we could set those as being maybe going, because those are values going, I mean, we could multiply those by something, right? We could maybe multiply those by 2. Maybe not 2, sorry. There we go. Well, I mean, it's giving us something, right? So, yeah, okay, let me see. So, we could map those values and say that they are starting from the threshold value and are going to a max of 255. And then we want to map them from 0 to 255. There we go. That's so we seem to have updated the saturation, right? A bit. I mean, I can zoom a little bit, guess, but not too much. But there we go. So basically, I'm saying that let's only keep the R value right now. Let me put this back to G and B, right? So let's see this. End of input. What's the issue here? Oh, there we go. Awesome. So right now only the R value is doing it. May not be showing much. There we go. Okay. So let's compare this to what we had originally. I mean, we're not seeing much of difference, right? Okay. I mean, it's definitely bumping up the saturation. I'm not a color guy. I wouldn't be able to tell you exactly what's going on. I've just try it out, make some modification, and just have fun with it. That's what I do, right? We're just having fun with it. Right now, I think it looks more saturated, sorry. So that's what I'm going to say, right? Let's maybe change this value to maybe, I don't know, 160, 165 maybe, right? So we're seeing different results, right? Because this it's taking anything that is that has a luminance less than 165 and making it black, and otherwise if it's 165 or higher, it's remapping every color in its pixel to be based from 0 to 255 and thinking that it starts at the thresholds of 165 to 255, right? So we have broader range of color, I believe. Awesome. So this is pretty much the filter that I want to use. Now, how can we set this as being a shader, right? So that's the end goal. We want the shader doing it, not our actual not the CPU, right? Because right now this sketch is executing just JavaScript code, which is executed on CPU. I want it to be executed by the GPU using webgl. To do this, I'm going to use P5 still, though I'm going to use some other language. So, well, we have currently only JavaScript language that we're using right now, but I'm going to create different files which are different languages. So let's get started. So we basically need to convert this which is our filter, into fragment code. So to start with, we'll need the shader file, which will contain a main function, and yeah, okay. So we'll create the shader.vertex file. Okay, great. And like we said, it's going to have a main function. So void main, parentheses open close, square bracket, curly brace open close, right? And maybe I need an extension, vert. Maybe there is no extension. All right, so we won't have color highlighting in here, but that's fine. in here, in the vertex shader, we will set one attribute, kind of a variable that gets passed from outside of the file. So the attribute will be a vector, so a vector of length 3, and the variable name will be called a position. Awesome. And then we're going to use it and set the GL position as a vec4, which is required to be a vec4. And the vec4 will be basically created from the a position with 1 as the last argument, right? This is basically setting, so basically this, what a shader does is basically going through and executing the same code for every pixel in our canvas. This is setting the position of the vertex shader, basically. Well, the position of the pixels within the shader, like from where to use it. We'll also create a fragment shader file. So let's call it shader.frag. Awesome. In here, we're going to have pretty much the same thing, void main. And the fragment is where we're going to have eventually our filtering of the image. So basically here, this function, this main function gets called for every pixel in our canvas. This one as well. The only difference is that this one, this vert, is to set the vertices in our shader, which will basically be every pixels. And this one is basically setting the color of that vertices, right? So in here, we absolutely must set the GL frag color, which will be a variable used by the shader to set the color of that specific pixel. To be vec4, to be again a vec4, and it's going to be R, G, and B, right? So right now we can try and see if we can get like a red, I don't know, red on the canvas from our shader, right? So basically this shader is a bit, it's not called stupid, but it's a bit weak right now. This shader is just changing everything to red. All right, so let's go back into our sketch and let's make it use the shader itself, right? So let's remove this right now. And now let's remove also the threshold we don't need. We'll just keep the image. And now we'll have the shader as well. So in here, we'll need to load the shader as well. So we can call load shader. And in this case, we'll need 2 arguments. The first one being our vert shader file, so shader.vert, and the last one will be shader.frag, or fragment shader. Awesome. This is not doing anything right now. That is totally normal. We'll bring back our draw function. There we go. And in the draw function, we'll need to set the shader of that canvas to the shader variable that we've created here. And then we can draw maybe a rectangle in the middle of the canvas. Well, just a rectangle, and for the full canvas. And basically what it's going to do is that the shader will be rendering on that rectangle. So first thing first, before I forget, I need to specify the renderer for the canvas, which is going to be webgl, right? Like we said. If we don't do that, well, I haven't tried, but I don't, maybe I've tried before, but I don't believe we'll be able to use the shader, right? So now we need to call shader, which is p5 function again, and pass it the shader itself that we want to use. Now, since we've done, since we've set the renderer to webgl, now the center, the 0, point of our, within our canvas is the center of the canvas. Before that, it was the top left of the canvas. So now just need to offset everything by, like, if we want to think of it as like the center being, well, the 0, point being as the top left, it would be like width divided by 2 and height divided by 2 minus. So let's draw our rectangle that we said we wanted to draw, and let's draw it from 0, or top left, which is in our case minus width divided by 2, since it's in the center currently, so minus width divided by 2. Right, so let's say this full white is our canvas. So in the center right now, and at the 0, right now, so minus width divided by 2, and then we'll do minus height divided by 2, and then we'll do width divided by 2, and then height divided by 2, right? So let's just do it. It'll be easier to do it like this. Divided by 2, and then width divided by 2, and then height divided by 2. There you go. Okay, awesome. So we have a rectangle. Let's not draw the shader right now, just to show you, and let's maybe set the fill color to, I don't know, maybe like some darkish color. There you go. We have a rectangle, which is supposedly taking up the full canvas, right? So let me zoom in a little bit. There we go. Well, not sure. Let me see here. Oh, I'll put back the pixel density. Yeah, I always forget about this. There we go. Now, anyway. I believe this should be it, right? Oh, no. Yeah, no. Sorry. Never mind. Well, we can keep pixel density of 1. That's fine. Yeah, sorry. I just forgot what the rectangle function is doing. It's taking up the corner left XY, and then it's taking the width and the height of that rectangle, which not the bottom right corner, but the width and height. So width and height of our rectangle. That makes sense. Okay, there we go. Awesome. So this is our rectangle that we want to apply the shader on. So let's remove the fill and let's apply our shader right now. So it's kind of, but not exactly doing what we expected it to, right? It's currently only drawing our shader was supposed to draw everything red, right? Every vertex is red. It seems like there's some issue with the vertices right now, because it's only using the corner right vertices, right? So in the vertex shader, we need to update something, right? It's because the vertex shader start at the center of the canvas, right? So vertex shaders start here, and we need to update the position of it to be at the bottom left corner of the canvas, right? So the vertex shader, how it's going, it's kind of flipping the JavaScript canvas, if you want to think about it. So 0 will be here, and then it's going up, and so the height is going up, and then to the right it's for the width, right? And we want to basically move this so that 0 would be here for the vertex shader, and then it's going to grow from there. Awesome. So it's kind of flipping the canvas, moving it to the center. So in our case, we need to move it back down, bottom left corner. Okay. All right. So in here, right, we need to set the GL position, so the vertex position, but not with what we currently have. We'll first create another vec4 So basically this is the type. So instead of const or let, you're going to use the type of the value you want for the variable. So I want a vec4, so a vector with 4 value. So I'm going to call this position vec4. You can call it pretty much anything, and then it's going to be a new vec4, and well, basically it's going to be this one, right? There we go. There, awesome. Okay, and now we will update the x and y value of that vec4, xy, and we're going to set those to the position, well, to itself, dot xy times 2 minus 1. Whoa, there. Okay, and let's take this one and set value over here, right? Okay. So we have to think relative to the vertex, right? So we're using 1 and 2, right? So okay, so it was half of the width and height, right? So our red that was there before was only half of the width and height. So we need to multiply by 2 to get the full width and height. And then we need to move it back by 1, which is 1 full, how can I say this? Because right now, these values are like all of the vertex values are from between 0 and 1. So we cannot like use the width, the actual width and height. It's based on the pixels themselves. We don't have any record or any knowledge of the width and height itself. We know only the position of the vertex, right? The A position right now, which is a vertex tree. But yeah, so we can see this makes it go through, right? And just to get a bit more information on this, like, so like I said, this is to get the full canvas, the full size, and let's say I didn't do -1. What do you think it's going to? What are you thinking you're going to see? Pretty much nothing different than what we saw before. It's because this is what we're seeing. Mode 2 is just creating it bigger. Checking the camera right now. Making it bigger, but there, right? So we're not seeing it. That's why we need to displace it by 1. 1.1. Yeah, that's important. If all of the vec4 are using float values, so decimal numbers, so we need to do mathematics based with decimal numbers. We cannot use like integer to do those. Awesome. Okay, so now that's taken care of. This is applied for every pixels on our rectangle, let's say. Now, we don't want it red, right? We want it, let's say we just want to redraw the image right now. We just want to redraw the exact image we had before any shaders. So we will need to get some image information in here, right? Because like, how can we know the pixel's color if we don't have the pixel information in the image, right? So to get that, we can do something similar to the attributes from here and pass in some values into this one, into this fragment. So to do that, we can go in the draw loop that we have in our canvas for our JavaScript P5 sketch, and we can add some uniforms to the shader. So shader.set uniforms, no S, I believe. Yeah. Okay. And the uniforms are basically just the name of their variables. So like a uniform would be any variable you want to pass it, right? And then you give it the name. I'm going to call it u_resolution. I'm going to pass it width and height. And these, so u_resolution is going to get passed to shader.frag as a vec2, as a vector2, as like the type vec2, since we've passed it an array with 2 values in it. And then I'm going to also pass, so we've passed the width and height right now, and let's pass also the image texture, right? So u image or just texture, u image. No. Let's pass it this u texture. You can call it pretty much what you want. And then we need to set the image here. Well, pass the image here. Okay, great. Now we can use those into the fragment. So the first one is just a vec2. The resolution that the u resolution is just a vec2, and the image P5 is converting it to a simpler 2D. So we'll have uniform vec2 called u. It's important that you put the same exact name as you did in the sketch, in the JavaScript file. Solution. And then we said that the other one is going to be a shader 2D. No, sorry. Sampler 2D. And I called it u texture. Okay. So we've got some errors. Let's see. Use program, sampler, uniform. All right, so I took some time, but there we go. Okay, so I figured out the issue. I was missing precision MIDI up float. Not exactly sure what exactly this is doing. I need to read a bit more on the subject, but hey, it fixed the issue. Awesome. Okay. So now we have our width, height in the resolution, and we have the texture of the image in here. So now let's try to just draw the image onto this rectangle instead of just color red, right? So let's first create the variable uv just for the coordinate, just so that we can get the color at that coordinate, right? So basically what we want is uv will just be the position in the texture that we need, like the index, let's say. So it's going to be a vec2, kind of a x and y, let's call it. Let's call this, we can call this index, doesn't really matter what it is. And then gl frag chord, so .xy, so this is the coordinate of the current pixel we are trying to update within the fragment. So this will be a value between, I'm not exactly sure, well, it should be a value between 0 and 1 for each of these values. And then we're going to use u resolution .xy and divide the first one by this one. And then we can set maybe vec4 color. Well, let's call the variable color, and this will be what we are going to use in the end over here, right? There we go. Okay, so color will be taken from texture 2D passing it our texture, so u texture, and passing it the index. There we go. Awesome. Now we see our image. The only issue is that it's flipped around, right? Because like we said, it was flipped around to begin with, whenever it was in the top left corner, right? Top right corner. Basically, it was flipped because the canvas was growing by going to the top and to the right. And was flipped vertically. And we only made it bigger and moved it down. We didn't flip it back again. So we will do this, but within our fragment shader. So basically what we want is to change the index y value to be equal to 1, because those values are all this index, all the values within index should all be between 0 and 1. So 1 minus that same value, right? There we go. There, cool. So basically just flipping it. Awesome. Now that we have it, we're pretty much done right now in terms of displaying the image. Now we can do whatever we want with it. We want to apply back our filter. Let's try first with the monochrome filter, right? The monochrome value, right? So let's have a float, and let's call that float luminance, like we had before, right? So this is basically just going to multiply. We're basically doing the exact same thing as before. So this dot R dot G and dot B divided by 3, luminance for, yeah, that, 3.0, yeah, important to not forget the float values. So now we can set, let's say, color dot R, G, and B equal to this, right? No, maybe we cannot do it like this. Anyway, doesn't matter. We can certainly do it like this. Well, we don't need the color anymore, to be honest, because we're gonna say that the alpha is always 1 in our case. So luminance, luminance, luminance for the R, G, and B, and then we said that the alpha will always be 1. There we go. So now we have our image as black and white, as monochrome. Cool. So R, G, and B. Yeah, that makes sense. Oh, why is there commas here? There we go. Yeah, it seemed a bit darker than it was. Okay, there we go. Cool. So let's see. Now we can threshold it. So we can use if statement in here. Though it's not the best, we will use if statement just because I don't want to take much time just making it the best. It's fine. So our threshold value, let's have a variable for that. So just like we had before, though this time it's going to be based from a scale to 0 to 1, not from 0 to 255. So we said about like 160 earlier, so let's say like about 0.5. Yeah, right, so it's fine. So if the luminance is if the luminance is greater than the threshold, well, no, sorry, if the luminance is smaller than the threshold, then the luminance is going to be equal to 0.0. Yeah, there. Awesome, so we have this back, right? So if I were to do like 0.7, you see pretty much everything's black. 0.5, let's keep it 0.5 for right now. Then we can add back the, instead of luminance being equal to this, let's do color, And so color would be color dot R is equal to luminance. Color dot G is equal to luminance. Color dot B is equal to luminance. And let's keep this like this. Let's put an else. I believe we can. And let's do something like well, no, let's put this here. So let's say that everything is black whenever it's smaller, and otherwise it's just whatever it was before, right? And then 0.0, yeah, I always forget. There we go. So this didn't change anything, though. Let's replace this by color. Awesome. So now it's either the color or the color gets changed to 0. And now we pretty much have the filter. The only thing left would be to remap the values, right? So this we can do by creating a function. So basically, we know in P5 there is the map function, the one that we were using previously to map from like the current value to from the threshold to 255, from 0 to 255, right? So this map function, we can just recreate this map function in here, right? So we'll have a function that will return a float. It's going to be called map. It's going to receive a couple of arguments. It's going to receive the value itself. It's going to receive the minimum, the first minimum, and then the first maximum, and then the second minimum and second maximum. Okay, great. So now we have our 5 values that we need, and then we can just use the same exact function implementation that is in the P5 library if you were to go and look on their GitHub. So basically min2 plus the value minus min1 times max2 minus min2 divided by max1 minus min1. There we go. That should be the map function. There we go. Okay, awesome. So now we just need to apply it over here. Let's do else, and let's copy this, paste it here, and let's replace all of these by over here. Let's copy this. Let's do map, paste this, which is going to be going from the threshold to 1 and going from 0 to 1. There we go. Now we've reproduced exactly what we had earlier. Awesome. So there we go. This is the filter. It's executing on the GPU. We can always pass the threshold. Let's say we wanted a slider for this. So let's slider, and then we can say slider equal create slider. I believe first value will be the actual value for it, and since we want float numbers, let's do 0.5 I believe here it's like the minimum, maximum, and then the steps. Or let me validate. Create slider. Let's see. So here, min, max, value, and then step. Okay, so min, max. Min is going to be 0, max is going to be 1. Value, it's going to start at 0.5, and then the steps, let's say that the steps are like that. Okay, cool. Okay, and then we can just do a new uniform called maybe u threshold, and it's going to be slider.value, I believe it is. And then let's get uniform float threshold and we'll just remove this. Yeah, there we go. Okay, so let's try it out. Not working. Let me see. Slider, does it get value? Okay, here. Slider.value. Yeah, it is like this. Okay. What is the issue then? Create slider, slider.value. Let's see, do we have any errors? No, it doesn't seem like we do. Though the slider, it doesn't seem to be doing anything. Float. Oh, it's not called threshold, it's called u threshold, right? We have to remember this. There we go. And here as well. Forgot the R in here. You need to have the same. There you go. Awesome. So let's close this. There you go. Now you can play with the threshold in real time and see it update, right? If we were to have this in here, like the filtering in here, it would be really slow. There we go. Awesome. So you can update this. You can add more variables you want to pass through, or uniform, whatever you want to call it. Maybe do some different filter. Make it so that you can still see maybe. So instead of this, you can do something like luminance, right? You can do pretty much what you want. This is not looking awesome, but yeah, that's you can do pretty much anything you want, right? Dot RGB equals this, maybe times 0.1, right? You can do pretty much what you want. Whoops, is it like this? I don't know. I don't do this very often. Anyway, just play with it. I'll put some references in the description. Leave some comments and have fun. See you in the next one.